Hello friends. Today we are going to discussing the topic operation of a transistor. These are the given points we will discuss in the class, that is terminals, biasing, operation and current equation. Okay. So this is the block diagram representation of NPN transistor, and I will draw the terminals of the transistors, that is emitter, base and collector. Okay, then emitter, base and collector, these are the terminals of a transistor. Okay, the terminals of the transistor and some basic concepts of transistors are uploaded in the previous video, so please check the basic electronic playlist. Okay, so and these are the terminals of the transistor. We discussed terminals of the transistors are emitter, base and collector. Okay, then we will move on to the next topic, that is biasing. What do you mean by biasing? In these three terminals we are applying a external voltage through battery. Okay, so when we apply an voltage through the battery, that is we call it as biasing. When an external voltage is applied the terminals of the transistor, that is we call it as biasing of a transistor. Basically the biasing of a transistor is two types. Okay, how it's come, that we'll discuss in now. Actually this is the representation of a voltage cell. Okay, voltage cell, and I am applying like that to base. I am applying like that, and in emitter terminal is connected to the positive. Sorry, first I am connecting like this, and next one I am connecting like this. So in this video we will see the operation of a transistor. This is the external voltage I given to the terminals of the transistor. So in this connection we see this is the biasing. We are doing an biasing on a transistor. Okay, next this is an NPN transistor. So we know that in N region the majority charge carriers are electrons. Okay, majority charge carriers are electrons. And here it is majority charge carriers are holes. Here it is also electrons. So the polarity or charge of electron is charge of electron. Charge of electron is negative. And in basic cell representation, this is the basic diagram of cell. This smaller region represented the negative polarity, and the higher longer length represented the positive polarity. So here the electrons are majority charge carriers. So in this region there is a negative polarity is higher than the positive polarity. So in this region, so here it is electron, so there is a negative, the negative nature is in n type. Okay, നമുക്ക് negative charge ഉണ്ടെന്ന് നമുക്ക് വിചാരിക്കാം. Okay, അപ്പോൾ negative ഉണ്ട്. Then the case of cell, there is a negative charge, negative terminals. So in biasing, I will write here, in biasing is actually two types. First one is forward biasing. And the next one is reverse biasing. Okay, what do you mean with that? Reverse biasing. Okay, then we are coming to the point. the biasing is two types, forward biasing and reverse biasing. Forward biasing means we are applying a external voltage just like that. The negative charge of cell and negative charge of the device. Here it is transistor. So negative, negative. The same polarity. It should be forward biasing. The negative terminals of the transistor is connected to the N region. So it is forward biasing. And the next region here, please notice that here it is negative. Majority charge carriers are electrons. So that here it is a negative push high charge, negative tendency. That means negative charge is here. Then N type material is here, so that the N layer is connected to the which region of cell? Positive region of cell, isn't it? So in reverse biasing, we are connecting, here we draw the cell in positive. So positive terminals of the cell is connected to the N region. That means N means negative region. This type of connection we call it as reverse biasing. Okay, actually the biasing is we studied in the diode in the case of PN junction diode. If you want the working of PN junction diode, please comment PN junction diode related video enannundengil, please comment in the comment section. Okay. So this is the biasing. So biasing is two types, forward biasing and reverse biasing. If we are applying like that, negative terminals of the transistor, negative terminals of the cell is connected to the negative terminals of the device. So it is, we call it as forward biasing. Like that, or we connect positive or positive. So it is forward biasing, and the negative means negative biasing. Okay. Okay. So, this is biasing is already discussed. Biasing is already discussed. This is biasing. So, in this diagram, we are applying a biasing. Okay, we are applying a biasing, and in this biasing, we will see two biasing. What is forward biasing and negative, reverse biasing. So, I will just draw like that. Okay, here there is a cell. Cell voltage and representations are denoted at the based on the working. So I already the last class we discussed in this is a BJT. BJT means bipolar junction transistor. So in BJT there is two junctions are here. So what are the junctions? Here it is, we will discuss. So here it is, we see that this is the emitter region, base region and the collector region. So two junctions. What are the two junctions of a transistor? So first junctions of a transistor is emitter base junction and the second one is collector base junction. Okay, so I will write here. Here it is, emitter base junction and next one is collector base junction. These are the two junctions of a transistor. So, two junctions of a transistor. Okay, so emitter base junction and collector base junction, and we are applying. So now we don't say like that we are applying an external voltage, we simply say like that we are providing a biasing, okay, to junctions of a transistor. So we are we provide a biasing through biasing it. Biased transistor is this. So when we are connecting like this, this entire diagram is, we call it as biasing of a transistor or transistor biasing. simply we call it as your wish. Okay, so emitter base junction and collector base junction. Then we are going to these separately in this junction. First junction is emitter base junction. So in emitter base junction, we will see that we have to in emitter base junction we see that there is a emitter base junction. Okay, so concentrate here. Sorry for that. Concentrate here. Here emitter base junction. In emitter base junction, which biasing is we provided here? Where we are providing forward biasing. Which biasing? Forward biasing. And collector base junction. Collector base junction, we provide reverse biasing. Okay, reverse biasing. So we will discuss. Forward biasing means negative terminals of the transistor is connected to the N region. So emitter base junction is forward bias and collector base junction is reverse bias. And in this type of connection, if the transistor is conducted like that, forward biasing and reverse biasing in two junctions, we simply call it as this is the normal operation of a transistor. Normal operation of a transistor. Okay, forward biasing and reverse biasing. So, what happened when negative charges are combined together? Okay, this is the normal operation of a transistor. So, when the transistor is operated in normal operation, we say that emitter base junction is forward biasing and collector base junction is reverse biasing. Okay, then we are move on to the what happened when negative charge. Sorry, we don't like negative charge and positive charge comes together. There is a attraction. Okay. Then what happened when negative to negative repel each other? Isn't it? Repel each other. Okay. So that when we are just think like this charge based on the charge, we see that this is the negative terminals of the transistor and this negative terminals of the transistor is connected to the negative terminal. So here is negative and here it is also negative. So when the negative terminals are held, so in this region there is a repulsive force. Okay, for that the negative charge, negative polarity and negative polarity, when negative charges are comes together, there is a repulsive force. Repulsive force is so what happened? Here it is, there is a barrier potential. There is a barrier width, potential barrier. So in forward biased condition, barrier potential is depletion region. That means depletion region. Here there is a N region and depletion region. So in emitter base junction ivade narrow aayittulla depletion region. Why it is narrow region? Because we are connecting negative. Based on the negative charge, there is a repulsive force. So all the electrons are move and the depletion layer width is so narrow. Okay. So forward biasing means what? Depletion. Depletion layer width is barrier potential. So moving like that. So we write like that. So that reduce the barrier potential. Okay, that is better. When emitter base junction is forward biasing, so that forward biasing means negative is connected to the end region. So negative, there is a repulsive force is here. Based on that, its barrier potential is reduced. What happened when barrier potential is reduced? Barrier potential reduce ചെയ്യുമ്പോഴത്തേക്കും the narrow depletion region ഇവിടെയാണ് depletion region ഉണ്ടാവുന്നത്. അതിൻ്റെ narrow ആയിട്ടുള്ള depletion region ആയിരിക്കും. So that we write like that. എന്താണ് narrow depletion region. Okay. Narrow depletion region. Okay. We all discussing only in the emitter base junction. So next we will move on the collector base junction, so that I will rub these all the points. So collector base junction. So the collector base junction is reverse bias. So what is reverse biasing? Negative set. So negative and positive terminals of the cells, and here it is the majority charge carriers are electrons, so that the end region, so negative. So positive, negative, and then there is a attraction. So attraction means this is the positive polarity, this is the negative polarity. So what happened when these polarities are come to each other? They attract each other. So what happened? The positive and negative, here it is the positive and negative, they are attract each other. So there is attractive force like this. Here the depletion layer width, a barrier potential is high. When? Because the potential barrier depletion layer width is large. So what happened? Attraction depletion layer expanding. Okay, expanding, so that what happened? Here barrier potential is high. Barrier potential is high. So this is what happened when we are operating in normal condition. So in transistor, what is the normal condition? Emitter base junction is forward bias and collector base junction is reverse bias. So we will discuss the operations region. Then in what happened? This is the normal operation. These are the factors that comes when we are operating in a normal condition. So that then we are going to discussing the based on the electrons and holes. What happened inside the transistor when we are applying like that? What happened? Okay, what happened? So here it is, we are applying a cell voltage across emitter and base. So battery voltage we write is that VEB, and here it is we are connecting the voltage VCB. We are applying the voltage across collector and base, isn't it? So we are applying biasing. We are operating in normal condition of a transistor. So what happened? And we already discussed in end region there is the majority charge carriers are electrons. When we are applying the battery of VEB, that should be higher the value of this barrier potential. That is, the value is already we discussed, that value is very low. The width, depletion layer is width is very low and barrier potential is reduced. So when we are applying a voltage here, that voltage must higher than the potential. Depletion potential higher. So when this condition is satisfied, the electrons are moved across to the base region. So what happened? These freely contained electrons, the valence electrons in the end region. So majority charge carriers are moved to base region. Okay, base region. In base region there is a hole. So here it is, there is some recombination process are doing, and here the majority charge carriers are holes, and here there is a base current is developed. After that, here it is, there is collector. What is the function of collector? It's collect all the electrons that emit from the emitter. That is the actual function of collector. So when we are applying the emitter base in forward biased condition, what happened is that the conduction band electrons, the N type materials are we used here. So in N type material, that means valence electrons, that is actually takes parts in the conduction process. So this conduction process is, the conduction electrons have enough energy to get when we are applying VEB voltage. When we are applying VEB voltage, we get the electrons, the conduction band electrons get more energy, so that the electrons are moved the emitter barrier. This barrier, electrons have to move based on that energy. The electrons are moved to the base region. Okay, so the injected electrons, that means these electrons, when it is reached to the base region, some electrons are lightly doped electrons. Here look at this region is P region. So here it is majority charge carriers are holes. That is why I am representing like this. Okay, so holes and the minority charge carriers are electrons, isn't it? So base is very lightly doped, and when we are emit these electrons in the P region, so there is so many electrons in the P region, isn't it? So the holes, some holes are recombination process are takes place. After that, the electrons are moved into the collector region. Okay. So in emitter base junction, collector base, we are comparing the concentration of electrons in the emitter base junction and the collector base junction. What the result we get? In emitter base junction there is a high concentration of electrons, and collector base junction there is comparatively low. And moderate range whole transistors biasing electrons in the concentration. So that in emitter base junction the concentration of electrons are high, and after that collector region electrons in the concentration base region